Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate projections of the oblique plane which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So here we have got a square lamina ABCD which is having edge length is equal to 50 millimeter and it has got its corner A onto the horizontal plane in such a way that its diagonal AC happens to be inclined at an angle of 30 degree with respect to the horizontal plane. So it means that the surface of the lamina, it is going to be inclined with respect to the horizontal plane in the first instance. So to begin with, we have to assume that this square lamina happens to rest onto the ground. So the top view projections, that is A, B, C, D of the square lamina will be drawn below the XY reference line to begin with. And once we are going to look at this lamina from the front side, so we will be able to obtain the edge view projections of the lamina in the front view, and the top view true shape projections of this lamina will be obtained below the XY reference line onto the horizontal plane. Now, since this lamina is resting on one of its corners in the horizontal plane, so let us first of all discuss about the orientation of this lamina with respect to the vertical plane. So if we locate this lamina into this orientation below the XY reference line and we incline the surface of the lamina with respect to horizontal plane at an angle of 30 degree, we will find that this lamina will be resting on one of its edges onto the ground. So this happens to be the incorrect orientation of the lamina with respect to the vertical plane and the horizontal plane. But if we are able to locate the square lamina into this orientation, then we will find that whenever we incline the surface of the lamina with respect to horizontal plane at an angle of 30 degree, it will be resting on one of its corners onto the horizontal plane. Or even if we incline it in this orientation, still it will be resting onto the ground at one of the corners of this particular square lamina over here. Now, second thing which has been provided to us, it is the diagonal AC is inclined at an angle of 30 degree to the horizontal plane. So this is the diagonal AC. So this point we are going to take as point A, point B, point C and point D. So this diagonal AC, so this will be inclined at an angle of 30 degree with respect to horizontal plane. After the first inclination of this square lamina diagonal AC with respect to horizontal plane, now this AC diagonal will be represented as an apparent length or a foreshortened length in the top view, and this diagonal which is BD diagonal, so this will be represented as a true length diagonal onto the top view projections. Why? Because this diagonal BD happens to be still parallel to the horizontal plane. Now the information we have, the second diagonal which is BD diagonal and this diagonal which happens to be parallel to the horizontal plane, so this diagonal is further inclined with respect to vertical plane at an angle of 45 degree. So we are going to have an oblique lamina over here and we are required to draw the orthographic projections of this oblique lamina, right? So with this information, let us proceed with the construction of the orthographic projections of this oblique lamina. So here we have got a square lamina and we have discussed that we have to draw the top view projections of this line below the XY reference line because the first inclination of the surface of the lamina happens to be with respect to the horizontal plane. So we are going to assume that this lamina happens to be parallel to and resting on the horizontal plane. So here we have marked an orientation of 45 degrees so that one of the edges of the square lamina will be inclined at an angle of 45 degree with respect to this vertical plane. So now this edge, this is edge point A, corner A, and this is the corner B. So the first edge AB has been inclined at an angle of 45 degree with respect to the vertical plane. So having marked this edge length is equal to 50 millimeter, now we have to draw perpendicular from the point A and the point B over here, measuring 50 millimeter each. And finally, we are going to join this endpoint C with endpoint D over here, so that we can complete a square construction having edge is equal to 50 millimeter. So the edge of the square we have marked as 50 millimeter, and one of the edges we have marked at an angle of 45 degree with respect to the vertical plane. Now we can check, this is the diagonal AC which happens to be inclined with respect to the horizontal plane. Now this diagonal should be parallel to the VP to begin with. Now we are provided with the information that this square lamina, it is resting onto the ground on one of its corners. So in order to tilt this particular square lamina with respect to the horizontal plane, we need to obtain the edge view. So we can check the true shape in the top view projections A, B, C, D has been obtained over here onto the horizontal plane. Now once we are going to look at this lamina from the front side, now we will find that since this lamina happens to rest onto the horizontal plane, so the projections of these 4 points A, B, C, D onto the vertical plane will reveal that we are going to get the edge view of this lamina which is going to rest onto the horizontal plane. So now let us find out the center location point of this particular lamina so that we can obtain the center point corresponding to the intersection of the diagonals AC and the BD over here. Now let us obtain the front view projections of this lamina. So points D and B, they will be projected as B dash D dash in the front view projections lying onto the XY reference line. Similarly, point A will be projected as point A dash onto the XY reference line, and finally point C of this square lamina will be represented as point C dash onto the XY reference line. So now having been able to obtain A dash, B dash, C dash and D dash, now we are going to join A dash, B dash, C dash and D dash in the front view. So the edge view projections of this particular lamina onto the vertical plane has been obtained. Now we have observed that this front view projection or the edge view projection, it is obtained onto the horizontal plane because the lamina is lying onto the ground. Now we have to incline this particular surface of the lamina or this diagonal AC over here. We can check, this is the diagonal AC corresponding to which the true length has been projected in the front view projections A dash, C dash. So this surface of the lamina we are required to incline at an inclination of 30 degree with respect to the horizontal plane in such a way that this lamina should be resting onto the ground on the corner A over here. So it has got its corner A in the horizontal plane. Now this true length, that is distance between A dash, B dash, D dash and the distance between B dash, D dash and C dash. So this true length of the diagonal AC in the front view, that is A dash, C dash, has to be rotated in such a way that it should lie alongside this projection line which has been marked at an angle of 30 degree with respect to the horizontal plane. So these 3 points we have got in the previous view. So these 3 points now we are going to mark in the new elevation projection over here in such a way that the distance between A dash and B dash, D dash, it should be equal to the distance between A1 dash and B1 dash and D1 dash, and similarly the distance between B dash, D dash and C dash, it should be equal to distance between B1 dash, D1 dash and the point C1 dash over here. So this way we have translated this front edge view at an angle of 30 degree with respect to the horizontal plane. Now since this diagonal has been marked at an angle of 30 degree with respect to the horizontal plane, that is diagonal A1 dash C1 dash. Now we are required to evaluate the top view projections of this lamina. So here the corresponding points in the top view we are required to obtain. And how the corresponding points will be obtained over here? From all these 4 points A1 dash, B1 dash, C1 dash and D1 dash, we are going to draw vertical projectors in the downward direction. And similarly from these points A, B, C and D, we have drawn the horizontal projector lines, and we will work out the corresponding points of intersections of this elevation view and this plan view which we had obtained previously. So we can check the vertical projector line through A1 dash and the horizontal projector line through A. They intersect at this point. So point A1 will be located over here. Similarly, the vertical projector through the point B1 dash and point B over here, they are going to intersect at this position. So the location of point B1 will be obtained over here. Then point C1 dash, we can see it is going to result in this vertical projector, and this has to be drawn downwards till the point it intersects with the horizontal projector which has been drawn through the point C over here. So we obtain point C1. Then the fourth point D1. So in order to locate corresponding point D1 in the top view, we have to draw the vertical projector through point D1 dash in the elevation, extend this vertical projector till it intersects with the horizontal projector line drawn through the point D of the plan of the previous view. So this way all the 4 points in the plan projection corresponding to the lamina which happens to be inclined to horizontal plane at an angle of 30 degree have been obtained. So now we can see, since this diagonal A1 dash C1 dash, it happens to be inclined to the horizontal plane. So the projection of A1 C1, that is the diagonal AC, into the top view projections, it will reveal the apparent length or the foreshortened length of this particular diagonal. Whereas the diagonal BD, that is B1 D1 projection in the top view, it happens to be still parallel to the horizontal plane. So we are going to obtain the true length projections of this particular diagonal. B1 D1 will be represented as true length in the top view projections over here. So A1 C1, it is the apparent length of the diagonal AC, whereas B1 D1, it is the true length corresponding to the diagonal BD. Now we know that in the second instance, the diagonal BD, which happens to be true length in this particular plan projection which has been obtained over here. Now this diagonal BD, it is parallel to the horizontal plane, and this is further inclined with respect to vertical plane at an angle of 45 degree. Now what we are going to do, we have to draw a projector line at an angle of 45 degree, and onto this projector line our points B1 and D1 will be located as B2 and D2 over here, so that the distance between O and B and O and D, it will be equal to true length over here, whereas the distance between points O and A1 and O and C1, so they will be represented as apparent length projections marked at a distance of this one OA1 and OC1 perpendicular to B2 D2 line over here. So please check, we have marked this distance B2 and D2. So distance of B1 and D1 true length has been marked as B2 and D2 over here. Similarly, O point will also be marked over here. So please check, this is my O point which has been marked. This is the center point of B2 D2. Now from point O, we are going to draw this perpendicular distance as OA1 and this perpendicular distance as OC1. So this way OA2 has been marked equal to OA1. Similarly, OC2 distance has been marked equal to OC1. So this way we have been able to rotate this figure, plan projection view, which we had drawn earlier at an angle of orientation of 45 degree with respect to the vertical plane, such that the true length diagonal BD, that is B2 D2, it will be lying at an angle of 45 degree with respect to the vertical plane. So having obtained the plan projections corresponding to this oblique lamina A2, B2, C2 and D2, now the corresponding points, they will be located in the elevation view as well. So in order to obtain the corresponding points, the vertical projectors from A2, B2, C2 and D2, they will be drawn upwards into the elevation view, and the corresponding horizontal projection lines we are going to draw from the 4 points A1 dash, B1 dash, C1 dash and D1 dash, and the intersection of the corresponding points will provide us with the locations of the points A2 dash, B2 dash, C2 dash and D2 dash in the elevation view over here above the XY reference line. So let us proceed. From A2, we are going to draw a vertical projector upwards, extend this up to the limit where it intersects with the horizontal projector line drawn through the point A1 dash. So this intersection provides us with the point A2 dash in the elevation. Similarly, from point B2 in the plan, draw a vertical projector in the upward direction till it intersects with the horizontal locus line or a projector line drawn through the point B1 dash of the elevation of the previous view. So this intersection provides us with the point B2 dash. Similarly, point C2 dash has been obtained while we have drawn a vertical projector through the point C2 and horizontal projector through the point C1 dash over here. And finally, we are going to draw the vertical projector through the point D2 over here, extend this vertical projector till it meets or intersects with the horizontal projector line which has been drawn through the point D1 dash. So we have been able to obtain the front view elevation projections of this oblique lamina A2 dash, B2 dash, C2 dash and D2 dash. So this way we have been able to obtain the front view projections and the top view projections of this oblique lamina. And this oblique lamina happens to be inclined with respect to the horizontal plane at an angle of 30 degree, and the diagonal BD of this lamina, it happens to be inclined with respect to vertical plane at an angle of 45 degree. So through this discussion, I hope that you would have understood about the procedure to evaluate the orthographic projections of an oblique lamina which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So this is all for today. So we'll be continuing with further discussion regarding few more illustrative cases of projections of the planes in the coming lectures. So thank you very much. Thanks a lot.